Hello everyone, welcome to this new TouchDesigner tutorial. In this series of tutorials, we're going to learn how to translate and interpret um, code made for processing on the generative design topic, but translated to TouchDesigner code. It could be made by nodes like this that is basic, or it could be made with Python. It depends on how difficult are the sketch for doing these processes that processing is doing. So we're going to, or I want to cover all of the sketches in the book. So as you can see, this will be long, but the main purpose is to interpret this or to be able to translate these codes between these two softwares. So there's already a translation of this book to TouchDesigner code. You can search it on the derivative wiki. Just search generative design and it will show you this page where you can see all of these sketches already translated to TouchDesigner. So basically what I want to do with these tutorials is to explain how to make this translation, because you can download these examples, but there's no any explanation of how this maybe this line of code in processing is translated to this node inside TouchDesigner. And also some things are quite different, like some resolutions we don't work here in this. The resolutions are different, or some behaviors are different. So as I studied these examples using also the book of generative design that I bought before, and recreating or retyping these codes on processing, you can look it there here. So making these three steps at a time, I could do a better translation of the processing output to TouchDesigner. So uh, I think these are a far away more detailed look like processing that these that are one that are here, but they are always helpful, because some things I have to recreate it like the way they are here, because it's the right way to do to do those that. So this is the book, and the book, but the difference that it has with the code that you can download is that the book explains some things that you can see. This market um, code, sorry, this market code is explained here. So also I will attach the picture to each chapter or each sketch, and this picture will be available for download to my patrons. So we can start. We're going to start with this one that is named Hello Color. It's a simple interaction of I had here opened. So if we would see it here on processing, it's a simple interaction of scale and color according to our position in the canvas. So I'm going to start a new file. And just hang on a second. Yeah. So okay, I'm going to close this. What's first? Okay, so first we always have in processing or setup. Uh, that is what is done before we start drawing. So we have here a size of 700 by 720 pixels. So we're going to make this in TouchDesigner, and we're going to do this with our panel, our main panel, so we can go up to this project that you can see that is a container. We can change it here to hello color, just to all. Okay, and width 720, height 720. So we already have the width and height that is on processing. And here on look, we change the background top to BG. Okay, so the next step here is to, as you can see, we have interaction on processing by default on the screen that is showing up. That's why we're going to work with these containers. So we can extract that information the same way, and we're going to do it like this. We're going to split left right or panels, and in the right pane we're going to select panel. So you can see here that is our square canvas, but there's no any other thing because our BG top is not placed here, and also we need a chop to extract the interaction we have here. So this chop is named panel. I don't know how to speak it right in English, but we have lots of information here that will be helpful for us in the next sketches. But here we can see we have this UV position that is similar to mouse Y and mouse X from processing. So we're going to select inside U and inside B as only want the inside position in our pane, and we can change it to mouse X and mouse Y. So we have no or interaction, but something that you can see here is that in TouchDesigner all our interactions or some things that we're going to do is normalized. So our values, no matter what values are, or maybe in this case, no matter how pixels are wide and tall is our canvas, it will always look between 0 and 1. So we're going to use sometimes this, and sometimes we need to change it to act like processing. So okay, that's the first part. The second part, if we go back to the code, we can see that we're going to change or we're going to use an HSL mode. So we're going to play with hue. Okay, and first what we're going to do is to change the color of our background. And okay, yes, so we're going to make our canvas, and this canvas could be done with a constant. So this constant needs to be like 720 by 720, and we can avoid using or typing this and referencing with Python code or sizes, because if we work with panels, we can use the parent panel size option, so it will always fit to the size, or we will always have the size that our panel has in here. So as you can see, 720 by 720. So another step to remember is that we need to be to work with HSB. We need to set our first color that we need to know that is red. So to make a red, we need to go down with blue and with green, and we have our red. So this will be like our background. We can also add a null here. This null will change it to BG, and now it shows up on the panel because we referenced it before. So the next step here is to make this to change this HSB. So we can do it like with this HSB adjust. So the same values that are here on the processing code are these ones, HSB. So the difference here, as I said before, is that some values are normalized in TouchDesigner. So maybe if our saturation here in processing is 100, or is the same that to have 1 in saturation multiplier here in TouchDesigner. So the same value that acts the same is the hue. So we can go from 0 to 360. Okay, so continuing then with this, we can see that our background, the color, the saturation and brightness will be remain the same, 100, but our color will be changing according to our mouse position. Our mouse position divided by 2, that is in processing all our values are in pixels, so our mouse position will be from 0 to 720 divided by 2, that is from 0 to 360. Okay, so we need to remember one thing before. Yes, and that thing is that the origin for processing to the positions and values is here in this corner, and for TouchDesigner is here. So we will have no problem with translation in X, but our translations in Y are inverted. So we're going to make it act like processing. So first we need here to attach a math to this panel. Okay, in this panel we're going to change our values. We're going to invert. If we're going from 0 to 1, we're going to we want, sorry, from 0 to 1, we want to go from 0 to 1. So here I invert to range 1 and 0, and now it acts like processing. If we want to check that is the same here, we can in the draw first print ln mouse y. Okay, so if we start again or sketch, we can see that if I go here down is 720, if I go up it will go close to 0. So yeah, we're acting the same here, but also we don't have the pixel value, we have this normalized value. So we can change this to the total value of our canvas, and that value is the Python script that is parent.height. So now we're going from 0 to 720. We are close to that, but here we can see that First, our values are with decimals, so we can avoid that with change it here to the integer. We can use whatever we want, so I can use round. And now our values are closed. The other thing here is that this math is affecting also mouse X, but I don't want to affect it. So we can use a select here and just use one and okay, so we can select mouse X, mouse Y and work with that, but we can also avoid using operators if we use the common page and the scope. The scope helps us to select which channels are affected by this operator. So we can bypass another channel and then we can save some CPU because we are avoiding to use more operators. So in this math we only need to use mouse Y. And then you can see that our value in mouse X is still the same as the input value in paint 1. So that's it. We can add a null, and from this null we can start using this value to our HSB adjust quant. So we can we need to drag it here to hue offset, and remember that it says that is the mouse Y value divided by 2. So that will be a full angle or full a full angle of 360 degrees. So we're going from red to red. Okay, so the next thing here is to set the rectangle that we're going to draw in front. That is wait a second, that is this. Where is it? Here, sorry. So that is this rectangle. So you can see first that if I move my mouse in the X position, it changes its scale, and it reacts also to the motion in Y position. Okay, so the code for this box is this one and this one. So first it says that we scale it from the center, so you can see it scales like a square from the center. So after that we need to fill it, but the inverse. So if we go from 0 to 360, here you see that we have 360 minus that value. So we're going from 360 to 0. When we are in Y position in 360, it will be 0. So it acts like the inverse. So this is the first thing that we can do, and it's very easy. We can copy this HSB adjust and just put before this code 360 minus this reference. And now you can see that we reach the ends with the same color, but we have inverted colors. The next thing is to use our translation. In this case is a transform. Sorry, to scale this this square. So okay, this square we can see that is in the position of the center of this processing, because it's 360 and 360, so it is here, and the value of this box is the position of mouse X plus 1. So if we are in 0 pixels, 0 position, our square will remain 1 pixel to have it there. So how can we do this? The first thing that we can see here is that our scale in this transform is normalized. So we can just direct this one, but we need to make the perfect translation. So I'm going to add here another math. This math, we're going, as mouse X is acting well, we can use this preset. So here we need to go from 0 to 1280, or sorry, to 720. That is our width. So here just change to parent dot width. Oops, width. Okay, so it's already 720. We need to also integrate to round, and you can see now we are affecting again to both of those, so it broke this one. So that's why it's useful this scope, because now we can select that this math only works on mouse X, and voila, we have our values. So remember, we are here on 0, but we need to just have always 1 to see our pixel. So we can add another math. We add pre-add, so we add 1. So if we are 0, we always have 1 before. And remember again, we are acting with we are acting with sorry, with mouse X, and it doesn't affect to mouse Y. So here is we are going to make the inverse. That is, we have now all the values we want, but as we are normalized here, we need to go back from 1 to our last value, to a value from 0 to 1, and we can do it in this same math. So we are going to use this expression that is backwards. We're going from full resolution to 0 1, and now we can see that if we are here, we always have this value, that is this one added. If we change it to 0, it will be 0. So just for clarification, we could also this operator, we could save it, and we can use this only 2, but I will have that side sketch available for my patrons, so you can see how to avoid this one. Okay, so last is to drag this mouse X to our transform scale, in this case chop reference, and it will reference the 2 scales, so it will be nice, and you can see right now is working well. The last thing is to add an over to make the composition, and now we will have this oh sorry, is over. Okay, over with transform 1 in the input 1, in HSB adjust on input 2. So you can see now we have almost well, the same behavior and the same resolution of this sketch. Okay, yeah. Okay, one last thing that we can do this, because if we go right this value, we can see our pixel, is to change all these operators to nearest pixel, so we can see that pixel, and sometimes it could be visible. Okay, so you can see it, there's already the pixel drawed, and if we have then this nearest pixel, it will disappear because it's very small. So I think that that's it. So I hope you like this. I think this is very basic, but remember we are following each chapter of the book, so we're going to start from very basic things, but it's for me it's fun how to translate code uh, between softwares. So I found this very funny, very exciting, and that's why I wanted to share what I will learn with this study of this book. So I think that's all. Remember, this file and the variation will be available for my Patreons. Also, the photos of the explanation of the code of the book will be in on Patreon. So any comment, any suggestion of this, please leave it on the comments. And I hope you find this course very helpful to understand how to translate processing code to TouchDesigner and how to think more like generative things in TouchDesigner, reactive things to mouse position, whatever. So yeah, have a nice year, and we see you later on this series, on this new series. Goodbye.